All right, I got September 26th. We're covering 7-1, 6-1, and possibly into 6-3 tonight. So first things first, systems of equations for linears. Basically a 2x2 system. And if you can look at this, you basically have three scenarios, right? You have where they, basically it's orientating two lines. So if you think about it, there's only a couple ways that you can orientate two lines. One, you can make them what? Intersect, right? All right. So if they intersect, the point of intersection, that dot, that point, that ordered pair, is the solution to the system. Okay? It works for both equations. Now, holy smokes, somebody turned this thing up to 85. I don't know. It's hot. All right. You could take the two lines and make a parallel, which means they'll never touch. They will maintain the same distance apart because they have the same slopes. So if they don't touch, then what's the answer? No solution. That's right. Because a solution is this, where they intersect or touch, right? So if they never touch, then they'll never be a solution. So hence, no solution. Now, the last example is you only see one. You're like, well, I thought you were dealing with two lines. Well, I am. But you can take this line and lay it smack dab on top of that one, and guess what? You only see how many lines? One. Okay? So how do two lines that are the same, how many times do they touch? Infinitely many, right? So now you'll get to look at these from a system standpoint, from an independent, inconsistent, and a dependent. Okay? So if they ask you what's an independent, dependent, or consistent, then you have these three pictures to go back and look at it from one solution, no solution, infinite amount of solutions, right? So you need to make sure that there are only three possible answers, period, on these, okay? They're either going to intersect, not touch, or be the same line, period. Questions? All right. All right, so it says determine whether 3, -3 is a solution to the system. Well, in order for it to be a solution, that means that the left side should equal the right side. Now, not only for one equation, but for both. It's got to work in both of them. So if we're looking at this, we're sitting here and we go, okay, that's 3 times 3 minus 4 times -3. It has to equal -21. Well, that's 9 plus 12. Does it equal -21, guys? -21? Nah. Did I do my math right? There's my X. There's my Y. So is this a solution? Nah. Right? That's the answer right there. Correct? So if we came on this and it worked for the first one, we would still have to check the second one, right? Because it could work for the first one, but not be a solution for the second one. Yes. It's just no solution. Not a solution. Yeah, not a solution. Because when you give you ordered pairs, they're just saying, hey, is this where they intersect? That's basically what you're saying. Because for an ordered pair to work in two linear equations, it has to be the point of intersection. All right, given the two intersecting lines, find the solution. Guys, what's the solution for this one? 4 what? Yeah, 4, 4. Over here, up, and there, that's 4, 4, right? All right, any questions on that? Now, it says solve the following system of linear equations by graphing. Well, they're both in standard form, right? And anybody know how we graph these from standard form? Anybody remember the discussions we've had in the past about graphing from standard form? I could turn it to slope-intercept form, right? But x-intercept, y-intercept, you remember the cover-up method? If I got my x-intercept, my y is what? And if I got my y-intercept, my x is 0, right? If you plug those in, those cover up, right? Y'all with me? So the purple one's going to be the top one. So I'm going to have a dot at, let's see, -1 and -1, right? All right, so I'm going to connect those dots in a second. And if we do the green, then x-intercept is -5, and the y-intercept is what? Just what? Just 5, right? So -5 and 5. Okay, let's draw some lines. How's the graphing part of the program in XYZ? Is it good or is it bad? Okay, so if we pull the XY axis, it should allow us to do what we need to do and go and do this, but I need another one, and I need it to be purple. So let's go find the purple there. Yeah, you see my problem? Is it going to cross at a pretty place? Anybody? Really? Okay. Probably so. My copy and paste probably distorted my graph a little bit. So you could turn around and take this and put it in what form? Slope-intercept form, and you can do your y-intercept, and then you can, y'all feel cool there? Yeah? See if it gets a little cool. Sorry. So you can get a little bit more precise if you go to slope-intercept form, but your program should hit it where you see that it's -3, right? So we're going to say, hey, do the copying, it should be right in there, right? Any questions? And sometimes when you copy and paste in graphs, they get distorted from a aspect ratio of the X and Y. So, okay, questions on that? Anybody? Excellent. Okay, now let's talk about some things. When you solve a system of equations, you can solve it by graphing, right? That's one way. But you can also solve it algebraically, and you can do substitution, and you can do elimination. Okay? Those are the two things that we're going to look at. We're not going to look at doing inverse matrices or reduced row echelon or any of those crazy things that you can do with a system. Okay? What we're going to do is we've got to make sure we understand that certain scenarios tend to lend themselves to being solved one way over the other, from a substitution to or an elimination, right? The only way that I will ever solve by substitution is if one equation is in standard and the other one's in slope-intercept or solved in terms of one variable, right, with a coefficient of 1. That's the easiest and quickest thing to do. So let's kind of look at this equation. We have 2x minus y equals 2 in one of them, and then we have x equals 2y minus 5. You can see that one of them's in standard form, right? And the other solved in terms of a variable, right, with a coefficient of 1. So it's already solved in terms of that. So what I'm going to do is I'm going to take, see this says x, and this right here is all x, right? I'm going to put it in right there. So I'm going to say 2 times 2y minus 5 minus y equals, guess what? 2. And this right here happens to be x, does it not? Okay, so I had this, and I just kind of went up there and put it right there. So I'm going to distribute. That's 4y minus 10 minus y equals 2. 3y minus 10 equals 2. Man, that is not going to work out pretty, is it? My math right? Huh? Okay, I was going 8. Okay, I'm with you. My brain was jumping ahead, skipping some steps, and it missed over that. So we get the y to be what? 4. Okay, so once we find one coordinate, it's really easy to go back in and find the other one because we're going to plug it right into the bottom equation. Once already solved in terms of x, that's the one we need. So x equals 2 times 4 minus 5, which is 8 minus 5. X equals, ladies and gentlemen, 3. Now, I can't leave it like that. No way, no how. I have to represent my answer as an ordered pair because, folks, when you solve and the variables don't drop, then you're solving for an intersection, and that intersection is a point, and that point contains an x and a y coordinate. So always make sure that you're putting it as an ordered pair. Any questions on that? If you've dealt with any kind of linear equations in your life, you've done systems. Okay. That calculator TI-36X Pro, it'll solve a system. You type it in just like it is, but you have to put them in standard form. So if I was going to take that, I'd put the 2y back on the other side and make it a negative 2y, and you just put in the coefficients and hit solve, and it does it for you. It's a pretty cool calculator. See me after class, I'll show you how to do it. It's worth the knowledge. Okay. All right. Let's look at this one. It says for this one, solve the following system for either x or y, and then use substitution method. Well, I'm not going to do that. I'm not going to use substitution for this. I'm going to use elimination. Okay? Elimination method is you're trying to get, here's the whole scheme to it. You're trying to get the coefficients to be the same number but opposite signs. So when you add them together, they eliminate themselves. They cancel out. Okay? And remember, you can have elimination in subtraction, or you can do elimination with addition, right? If you're going to do subtraction, that means you got to make them exactly the same. And then just subtract all the way through the equations. That's the biggest mistake, because people make a lot more mistakes because they don't carry that negative. When it gets to a negative, when you subtract the negative, it becomes a positive, and people mess that up. So the easiest way to do it is to make sure that you make sure that they're the same number but opposite signs. So I'm 9 times out of 10, I'm going after the x because it's right there where I'm working at, right? So I got a 1 and a 1, right? That's great. But I'm going to use elimination. So that means I'm going to take one of them and multiply everything by, guess what? So I've got this, and there you go. That. And then I'm just going to come out here and go, okay, I'm going to add them together. This becomes 0, right? This leaves me with negative y equal to 1. And of course, divide both sides by negative 1. Y equals, guess what? Negative 1, right? Any questions about that thus far? You okay? No? Yeah. Yeah. After 1,500 of them, you'll be okay. Well, no, let's see. How many problems are there? There are probably, I don't know, 10 or 12 in there 6 times. So you got about 100 you could do up to it if you wanted to. All right. So once I find what y is, I'm just going to plug it into either one of these equations. Why can I plug it into either one of the equations? It's both a solution for, the point is the solution for both equations, right? So what we're going to do is this. There you go. It's just, yeah, you could take the 2y over, right? You could take that 2y and isolate the x if you wanted to, right? And then substitute in and do all that. But it's just, they're already in standard form, guys. Elimination is the way to go. Okay? So I really don't care what method you solve it in. You choose. Any questions on that? No, y'all good? Sweet. Okay. Now here's this one. It says solve by elimination, right? So I need you to take 10 seconds. Don't do anything other than just look at it for 10 seconds and think about a plan of attack. Okay? 10 seconds. Go. Okay. So what would be your first move? To multiply the top one by -1? Ah. All right. So you really have a fork in the road. I said I always try to attack my x's, right? So I would, if I'm going after the x's, I'm going to have to multiply one of them by -1, right? But before you do anything to your x's, always check to see if your y's are the same number but opposite signs. No, you can't do that. Well, then you're stuck with doing extra steps. That's fine. It doesn't matter. But it's all in what you see or remember, right? Because if you don't see that, then okay, no harm, no foul, right? But if you do see that, then you will see that when you add these together, these y's will automatically do what? Cancel out, right? Yeah? So, no. If you want to try to make the x's go, yeah. But if you just look at it and say, hey, I ain't got to do the x's, anything to the x's because my y's are already +1 and -1, right? I'm trying to get the coefficient on one of the variables to be the same number but opposite signs. That's my objective. Okay? All right. So let me throw some theory in there real quick. When you're solving them algebraically, you're going to primarily see where they intersect, right? But what does it look like in order to get the other two types of solutions algebraically? What has to happen? You don't remember? Now t equals 0. Yeah. All right. You're headed down the right path. If you ever get into a problem where you're going to eliminate one of your variables and it happens to eliminate both of them, both your x and your y drop, then you're left with one or two cases. You're left with a number compared to another number, right? Y'all, okay? So if these two numbers are not the same, then that is a no solution. But if these two numbers are the same, then that is infinite amount of solutions. Y'all remember when we done that when we were solving equations? We had some, variables drop when we were solving equations way back when. Y'all remember that? It's like back in August. It seems like only yesterday. All right. So I'm just going to add these, right? So that becomes 2x equals what? 8. So x equals 4. So I have 4 plus y equals 9. So negative 4. So y equals what? 5. So I have 4 comma what? There you go. Questions? Oh, good. X, you okay? You sure? All right. I went ahead and added these because these met the criteria that we were talking about. Okay. So, all right. Okay. Dang it. Okay. I'll let you work this one. Let's see what you can do. Okay. Let's see what you see and which way you go. I'll give you, how long do you need? You want a minute? Give you a minute head start. Now start working and then we can talk. All right. All right. Stuff. I don't like that one. All right. So I'm left with -7 and 7, right? Okay. On this problem, once I found the x as being -7, I started to use the top one, and I stopped. Anybody know why I stopped? It would work. It'd be great. Anybody know why I stopped? See that -y? It's great. I can take care of this, move it to the other side, but I was going to have to turn around and divide by what? -1, right? Or multiply both sides by -1. And I wouldn't have to do that if I'd done it down here, right? So that's why I backed up and punted on that. Any questions? I'm hoping I pulled one, and I should have probably grabbed one that did the variables drop, right? So you could see it, but hopefully, I don't know. Maybe there'll be one. Any questions on this? No good? Yeah? All right. Here we go. Let's see what you can do with this. Huh? Multiply the top by 5, right? So multiply everything up top by 5. So that's -5x, -15y equals 5. And then, of course, just bring the other one over. So that's 5x plus 10y equals 5. And then add them together. And then you get -5y equals 10. And, of course, divide by -5. So y equals -2. Any questions on that? How many equations do I have to plug this back into? How many? 3. I have these two plus the modified one. The modified is one that I can use because In algebra, if you do something to one side and you do it to the other, then you've created an equivalent equation, right? So just keep mind of that. Most of the time we go back to the original equations just because if we have made a mistake or something like that, it's not compounded. No, we don't do a system of three. Nah. Nope. Nope, 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 nope. If we were teaching, or if this was the math modeling class, then yeah. But you do it on the calculator. And the only time it takes to work it is time to plug in the matrices. And you do reduced row echelon on it, and life is very easy. I got 5, -2. How'd we do? Y'all rocking and rolling? Y'all wait. The rain is kind of, yeah. Okay, y'all ready? I put this in on here because I had fractions. And I was like, okay, which problem would give them the hardest time, or they would say unpleasant things about? So those are kind of how some of my thought process when I go through and choose these problems for you to do. So anybody know what I'm about to do? I'm about to make these things pretty. And what I'm going to do is a process called clear my fractions. If you look at my first equation, I have 6, 4, and 12, right? 6 won't go into 4, 4 won't go into 6, but they all go into what? 12. So I'll multiply the top one by 12. So that will give me 2x minus 3y equals 5. So if I distribute that through, that's what it gives me, right? And looking at the bottom, I have 2, 6, and 3, right? Well, shoot, I'm going to multiply that thing by 6, right? And that gives me 3x plus y equal to 2. Now, that's a whole lot prettier than that convoluted thing that they gave us to begin with, right? There you go. Now, how you want to attack this? Do you want to do your x's or do you want to do your y's? The y is probably the easiest, but I'm going to show you on this one how to do the x's if you have to do a double multiply. Is that okay? So the y is the easiest. Just multiply 1 to get the y to cancel, right? Multiply the bottom by 3, I think. You should be okay. But 3 won't go into 2. 2 won't go into 3. But they'll both go into what? 6. So what I'm going to do is I'm going to multiply one of them by -3 and the other one by +2. I could have put +3 and -2 if I wanted to. Doesn't really matter. I just need to get one of them to be -6 and the other one to be +6. And then I got 6x plus 2y equals 4, right? Now, that gives me 11y equals to what? -11? So y equals -1. So if y equals -1, then I can say 2x minus 3 times -1 equals 5. So 2x plus 3 equals 5 minus 3, so 2x equals 2. Divide by 2x equals 1. So I have 1, -1. That's my answer. Y'all good with that? Pretty much the same thing that we've been doing. We just had to clear fractions. Okay. That's right. Yeah. Because what you're creating are equivalent equations, right? As long as what you do to one side you do to the other, you could multiply them both by 100 if you wanted to. Or 300 and 200 if you want to. Yeah. Yeah. You're trying to get the same coefficient but opposite signs. That's the only objective. Yeah, you can nerd out so you can. Yeah. I teach this in 8th grade, solving systems. Yeah.
Either coefficient, whatever you choose.
Didn't matter.
Opposite sign.
Yes, sir. Yes, sir. Got to be same coefficient but opposite signs. And I could have chose -2 and +3 to be multiplied, right? Which would have made the negative be down on the bottom, right? I'd still come out with the same answers. So, yeah. All right. Yeah, an 8th grade mind doesn't truly appreciate the equivalent equation thing. They're just happy to go to lunch and come back. But, all right. Okay, guys. Word problems with systems. Y'all ready? Let's go. The sum of two numbers is 30. One is 4 times the other. Well, do we know what those two numbers are? Nope, we don't have a clue, right? So x equals one number, y equals what? Second number, right? It doesn't matter, right? X equals first and y equals second. Now, the sum of those two are what? 30, right? They gave me a relationship. But before I do that relationship, I have to identify who my x and my y are, right? That's so critical when it comes to doing these word problems. Got to identify who your x and y is. Now, so we got the sum of those two numbers is equal to 30. One is 4 times the other. Well, x equals what? 4y, right? Or I could have said 4y equals what? X. It doesn't matter, right? But as long as I put one is equal to 4 times the other, that's the key. Now, what way do you think we ought to solve this? Just plug it in. Plugging in wasn't one of those methods. What was the method? Substitution. What is substitution for 5,000? We know what you mean. All right. Yeah, okay. So plug that in there. So it's 4y plus y equals 30. So 5y equals 30. Y equals 6, right? So if y equals 6, then x equals 4 times 6, which is 24, right? So I got 24 and who? 6. So it just says the smaller number is blank, and while the larger number is blank. So the smaller number is 6, while the larger number is what? 24. All right. Now, what I should have went back and asked is any questions on coming up with those two equations in red that I highlighted. Anybody? You would have got one number to be, y would have been 24, x would have been 6. So, but you're going to come up with two numbers I had to give you 30, but okay. The really cool thing about these, they're algorithmically generated, right? Which means what? The process doesn't change. Only the numbers, right? Okay, be mindful of that. All right, so most famous system of equation problem is the coins, right? So Ron has 17 coins with a total of total value of $2.45, right? The coins are dimes and quarters. How many of each coins does he have? So first things first. X, hold up. X and what? So we gonna make X dimes and Y is what? Quarters. First things first. Got to do that, right? Okay. So when you have a equation like this, or a word problem like this, you have to understand that, excuse me, that systems work in patterns. And these patterns happen to deal with totals and then values, right? Totals and values. Look at the previous problem. They said the sum of the two numbers was 30, right? So that's a total, correct? So how many coins do we have? 17. What are they comprised of? What are they made up of? Look at this. X plus Y equals 17. Okay? Any questions about that? Okay, the next equation will happen to deal with a value. Because not only did they tell us how many coins and the denomination of the two coins, they told us how much money we had in value, right? So they told us we had $2.45. Now, you can do this with decimals if you want to, but I'm going to show you how to do this in terms of no decimals, meaning cents, right? Y'all with me? So a dime is worth how much? 10 cents plus a quarter, which is 25, equals 245 what? Cents. There you go. No decimals. You write it all in terms of cents, right? So there. Now, what do you think is the first thing you're going to do? We're going to use elimination. Well, we'll multiply our top one by what, guys? Negative 10, right? So, go ahead. Solve that joker. All right, so they said we had 12 for dimes. And then how many quarters? 5. Okay. Everybody in agreement? Speak now, forever hold your peace. No? Do I need to work it? Yes or no? Huh? Okay. Well, 5 quarters was y, right? So you're going to plug it back into the top equation. X plus 5 equals 17, minus 5 on both sides. And you got 12, right? 12 dimes. Okay? So, all right. Okay. The famous mixture problem. Now, we can do this with a system if you'd like. Or we can treat this just like a linear equation and not do a system. How would y'all like to do it? The easier way. So let me show you the easier way. The easiest way is to do a table, y'all. So, and what I mean by table is, I hope I do this right. I think I need that. Yeah, 4. Good. Got it. Good. All right, so see, you can't do this. I can. So we have next one, or I should say, and let's do this. Amount, percent, solution, and then total, right? And then items, correct? So we have a mixture of 6% disinfectant solution that needs to be made from a 7% to 4% disinfectant. how much of each solution should be used if 33 gallons of a 6% solution are needed. Okay, so we're trying to make a 6% solution, right? And we're trying to make how much of it? 33 gallons, right? And we know that this 6% solution is 6, right? Y'all agree? Okay. Any questions about that thus far? Now, the two items that we're using is this. We're using a 7% solution, right? We don't know how much, right? Do we? But we know its solution is what? 7%. Now, the other one is a 4% solution. We don't know how much, do we? But we do know that it's 4%, right? Y'all agree? Okay. Would you believe me that you're 85% done at this point? 85% done with this problem just by doing that. So we have an item, right? We have an amount, we have a percent solution, and then we have a total, right? So what's this? How much do we have of the 7%? How much? No. We got 33 of the final solution, right? How much do we have of the 7%? We don't know. So what do we do in math when we have a I don't know? We put an X. So if that's X, then the other amount has to be what? 33 minus X? Right? Yeah? So, what's this? So stop, drop, look, and listen. X times 7 is what? 4 times this is 4 times 33 minus X, right? And then 33 times 6 is 180 plus 18, which is 198. Right? Double check my math. Yeah. Okay. All right. So watch this. These two added together has to equal what? 198. 7x plus 4 times 33 minus x equals 198. Done. Solve the equation. That's all you're doing. X is 22, right? Yes or no? Okay, so X belongs to who? To the 7%, right? So I have 22 gallons of the 7%, and then 33 minus 22 would be what? 11 gallons of the 4%. I'll leave that right there. Take a look at it. Okay, here we go. Another famous one is ticket sold, right? We're going to do this just like we done the quarters. Just like we done the quarters. So we're going to have a totals and a values, right? Totals and values. So, look through it and let's see. Well, let's do this so that everybody's on the same page. We're talking about two types of tickets, right? Yeah? So let's go ahead and define X as being a child and Y as being an adult. Can we go ahead and do that? Because that's really the first thing you got to do. Now, You go through it. You write me 2 equations, and we're going to compare. Because that's the hardest part. You can't work it unless you write them. Okay? So go. How do we do? I'm going to put that 1x there. Does mine look like yours? Yeah or nay?
Yeah.
What do you mean you swapped it? Yeah, but that's the first thing we said. Make x the child, y the adult, so we'd have the same. But it don't matter. As long as you make that determination and stick to it, you're fine, right? So x plus y equals 800. And then 1x plus 2y equals 1225. If you swap the adults and child, then yours would be 2x plus 1y equals, right? Yeah, you still get the same thing. Anybody, what do you get? What'd y'all get? Yeah. You got a what now? Y'all agree with that? Yeah? Y'all are mighty trustworthy, right? I got 375 and 425. Y'all good? You see what I done right there? No? System sauce. You're putting in the coefficients. Coefficient X, coefficient of Y, and the other one, right? But it's gonna when you hit enter, it's gonna go to this in case you need to change it to a minus. Does that make sense? When you do it, you will. Come see me. All right. So what was it again? X is what now? And then 425, right? So 375 child and 425 adults, right? If I have to solve this by elimination, I'm multiplying the top one by a negative, right? And then add them together, and then it just kind of cancels out and goes from there.
When I first did, I tried to go for the X's, but I ended up with a decimal when I did the. Yeah, it was weird. I ended up with like 141 point something.
Here?
Yeah. So
Which one did you do with the negative?
no,
Top or bottom?
I multiplied the top one by -1.
Okay. Can't come up with a decimal because your coefficient's 1.
Hold on, I think I did minus.
Can't. Yeah. All right. So we got 375? No, 425, right? Yeah. There you go. And then plug that back in. 800 minus those, right? Yeah. It's okay. You all right? Yeah.
What confuses me is when you get on the second one, you got x plus y equals 800, x plus 2y equals 425.
So the first one is a totals. How many do I have? Right? And the second one is a value. How much does a child's ticket cost? $1. $1 times how many of the child's tickets plus $2 for an adult times how many tickets were sold will give me a profit of or in a total amount of $1,225. So that's really what you're doing. Dollar times amount plus dollar times amount equals a dollar of all that, right? So it's a value equation. What is the cost of my child? What is the cost of my adult? How much money did I take in? Okay. It's kind of like, what's the,
So put in $2 and $4, 2x,
Mhm.
4y.
Yeah. And it's the same scenario as the coins, right? Think about it. The second equation was 10x plus 25y equals, and I changed that into cents, right? By just dropping the decimal. So that's the key on that one. Okay. Y'all good? Yeah? Wake up? Sleepy? No? Okay. All right. We've done one of these already. We did one of these in the first section, right? I'm not going to do it with a system. But I am going to set it up in how you should do it, right? And that's this. So we have 8% times some amount, right? Plus 10% times some amount, right? Equals $2,040, right? Oh, it's 12%? Okay, not bad. Is it 8%? Okay, got this. So that's 0.112, right? Now, because this is like the simple interest, right? I equals PRT, right? The principal times the rate times the time. Well, the time is all the what? Same. So that really just goes to the wayside, right? So interest is equal to the principal times the interest rate. Now, interest rate has to be as a decimal. That's the kicker. That's the key. You got to make sure. So how much did we put in at 8%, guys? Yeah, we put X in. Yeah, we put X in, right? Sure enough. Now, how much did we put in at 12%? 21,000 minus X, right? You can do this in a table if you want to, right? There's ways to show this worked out so you can plug it. I mean, if you think about it, P times R equals that plus this has to equal how much interest, right? So a table sets up real nice, but this is, we've done this one before, guys. So solve it. Tell me what you get for X. $63. No, can't be. That can't be right. What'd y'all get? Can't be 63,000. I've done something wrong. Oh, I know what it was. Sorry. 2520 minus 2040 divided by 0.04. How about 12,000? Did you get 12,000? Yeah. So the 8% account got 12,000, while the 12% got what? 9? And that's math. 12 and 9 make 21. Yes. Thank you. Distribute, combine like terms, move the number over to the other side, and you'll have a negative divided by a negative, right? And that's okay because two negatives make a positive, and that's what we want anyway. Y'all good? Okay. Anybody want to see this in the system? You want to see this in the system? Huh? You want to do a system? It was? You liked it? Well, here. But you should have what? X plus Y? Mm-mm. What is it? X plus Y equals what, guys? Is it the interest?
Yeah,
No. It'd be how much? Because X and Y is the principal, right? Oh. Well, I was still debating. And then I have what? 0. Do you want to do? Oh, yeah, we got to put 0.8. We have to. Sorry. Then 2040, right? Riley, you agree with that? Yeah. It's just, I don't know. It's my brain just doesn't go to a system on that. But you can do it. Really? Yeah. Yeah. It depends on how what you see and what you're comfortable with, right? That, so it doesn't matter to me. You got multiple ways. Pick one, but you got to pick one, right? All right, you good? Sweet. Okay, last one on this one. A stuffed animal business has a total cost of production of C of X equals 12X plus 60 and a revenue function of R of X equals 20X. Find the break-even point. Well, folks, where do we find the break-even point? Yeah, 0. But how you going to do that? You got a cost, you have revenue. It's when they're what? Equal, right? Their difference has to be what? 0, right? Does that make sense? So, yeah, we're just going to put 12X plus 60 equal to 20X, right? And, of course, we move that baby over. So 60 equals what? 8X? All right. 8 didn't go into 60. Yeah, we could. We could. We could have some change. Let's go get some change. 750. Now, what do I do with that 750? If I put it in the first equation, and if I put it in the second equation, I better get the what? Same thing, right? So 20 times 7.5 is 150, right? Then 12 times, times 7.5 equals 90. And 90 plus 60 equals how much? Voila. So they break even at what? 750 when they're both, or 7.5, I should say 750. 7.5 things, or whatever they got. I don't know how you could have half a thing. The body wouldn't. No, it's not population. So, I mean, it could be a fruit, it could be half a pineapple. Right. But if it's a produced product, then you can't sell half the product, right? I mean, would you go buy an Apple phone that just had the screen and the back into it with no guts? Yeah, I mean, would you want that? No.
Does that mean there's no true break? You're either gonna lose or
Depends on what this is. It really, the numbers are driving the scenario, right? But the scenario might be, hey, I mean, you do the string of fruit all day. You go to the grocery store, walk down the fruit aisle, right? Or the produce aisle, I should say. What do you see that's normally cut up? Cantaloupes, half a cantaloupe, you do half a watermelon, right? Um, they normally spiral the pineapples, right? In half.
Not half, just cut in cubes.
Really? Yeah.
They're just a lot more expensive.
Yeah.
Like canned fruit.
Canned fruit. No. Fresh is better, okay? Fresh is better. Yeah. No. No, it's not all the same. Okay. We're done with what your test is going to open with on Sunday and close on the following Sunday. That's it right there. Okay. So there. Huh? Well, we ain't done yet. Oh, fruits. Yeah. All right. Yeah. All right. Now we're going to do exponential functions, which is the greatest topic of all times. Y'all are dead. Like, well, I'm waiting for the I'm waiting for the morgue to come pick you up. You know, I just don't know. Exponential functions. Okay, 6.1. Um, it's in the form of a times b raised to the x, right? Now, primarily, we will see exponential functions with the a being a 1. And when that happens, all you're seeing is like 2 raised to the x, 3 raised to the x, 4 raised to the x, and so forth, right? That's primarily how we see them. A is 1, right? So it doesn't bother. But you got to make sure you understand some things because there are some criteria that you must meet in order to be a exponential function. Okay? A is a non-zero real number called the initial value, right? What did I have in the very beginning? That's really what A is, right? So when we're looking at this, and we'll do some word problems. So when they talk about in the beginning, that's your A, right? Yeah, you got to remember that. B is any positive real number such that B can't equal 1, right? Well, B is the base, correct? B is the base. And the base of that exponential can't equal 1. Why? Why? What do you mean it'd just be 1? Yeah, there we go. Now, you got to understand why it can't be equal to 1. And that's it, right? If the base is 1, 1 raised to any power is what? 1, right? That's when we done the imaginary, the I to 28, what is that? All that stuff, right? Hey, that's a really good problem to have on the final 2. Evaluating I's. Huh? Yeah, I'm just telling you. I mean, it's like flashbacks, like, remember stuff. Okay. Uh, okay. The variable has to be in the exponent, right? Okay. The base can't be negative. It has to be greater than 0, but not equal to 1, right? And the x has to be up in the exponent. Any questions? So that's the criteria. Now, domain and range, listen. You know what an exponential looks like, right? Yeah, graph. Not the equation, sorry, the graph. Anybody not know what it looks like? Me too. Let's go. Let's go do it. I get nerd out on my calculator. It's just like this one. You know, people have video games and all that stuff. I have my calculator, my emulator, my TI-84 CE emulator. Okay. All right. Here we go. Let's just say 2 raised to the x, right? Then, let's just go ahead and do this while we're here. So that way you can see it. Man, that's great. Man, this is going to be awesome. All right, so that's good. Yeah, that'd be good. Yeah, that's wonderful. Graph. All right, so I need to kind of zoom fit. I like that. Nope, I don't like that one bit. Okay, there. All right, so it comes in a growth, that is. That exponential that's growing starts over here, way out here, right? And the negatives, right? Way out there. Now, see this x-axis? This x-axis is an asymptote. Okay? Asymptote. An asymptote is a line that the function approaches but does not touch, right? We've said that. So, can you, if it's going to grow, can you start with nothing? You can take nothing and make it grow? Can you work that on my checking account?
I wish.
Jeez. Man, it's a miracle worker there. You have to have something in order to make it grow, right? Let's think about this. You get exposed by the cough, right? That cough has germs in it, right? Germs get into your body, correct? And then they start to do what? Multiply. They start to grow, right? So they're little itty bitties, right? And then they grow and 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 grow, and then all of a sudden, voila, they take off, right? Like they are all over you. You feel like you've been hit by a Mack truck, right? So, but they started out from a little thing, right? We can't sit here and go, 2 years from now, let's come back and see what that is. Because there ain't nothing there. Huh? There ain't nothing there.
There is something there.
Oh, so there has to be something there for it to grow, right? Okay, good. So a growth exponential does that, right? Okay. Now, I put 2 to the x, 3 to the x, 4 to the raised to the x, and 5 raised to the x, right? So I went blue, red, black, and purple, right? So look at this. As the base gets higher, goes larger from 2, 3, 4, 5, what does the exponential do? It gets steeper because its outputs are much greater. Let's think about 2 squared. What is 2 squared? 4. 5 squared is what? Do you see how much different? I mean, that baby's taking off, right? Okay, so you got to understand some things like that. So if you've got a growth that looks like this, guess what else you can have? A decay. So you want to see what it looks like? Yeah, let's do it. Why not? Y'all like, whatever he wants to do, let's just do it. Yeah, I need to find out who said something about me teaching these face-to-face class, because now I've got a face-to-face class next semester, and I've been normally teaching online classes. So the guilty party will bark. Miss MK, it's not right. Huh? I didn't even check my schedule, but I got told that I'll have a face-to-face. Do a face-to-face. I like being anonymous. Yeah. No, no, no. I'd rather be with y'all than any graveyard in the state of Georgia. But I'd rather be with my family more. I miss my family. No, it is not. You just got to learn how to appreciate them. And make sure you have multiple rooms in your house. That's okay. All right, so I went 2 to the negative x, 3 to the negative x, 4 to the negative x, and 5 to the negative x, right? And so it's right back. It's like a reflection about the y-axis, right? It's like turn them, right? And like after we get sick and we take that medicine, right? The the all that virus, all that bacteria starts to do what? Yeah, does it ever really go away? It depends. Come on now, depends is what old people wear. Huh? They eat their own? What is this? Oh, come on. Does the virus ever go away?
Your body would remember it if it ever was tried to attack again, so then that way you don't get sick with the same thing.
The bacteria will not stay in the body.
Okay. Y'all ready? Nah, I know y'all just about done anyway. So okay. So we're gonna go. We got to understand some things. So we looked at some graphs, right? We looked at growths and all that other stuff. Um, how to? Don't worry about that. I'll teach you that. Don't worry about that. I'll teach you that. Hey, we won't ever do that. Yeah, but we'll do compound interest. So this compound interest thing is pretty cool. N on this is the number of compoundings per year, and that could be 2, 4, 6, 12. It doesn't matter. Okay, but they'll tell you words like quarterly, monthly, daily, weekly. So those correlate to numbers, and that's what's going to go in the end. Okay, and then of course we all want the well, we'll talk about E. E is a natural. It's a natural exponential. It's a base that basically how everything in nature grows by some constant rate, and that constant rate is E. Okay. Um, Continuous growth and decay. We'll figure out what it means to have continuous growth. We'd love to have savings accounts or 401ks that have continuous growth, right? They just it's continuous. So, all right, we'll teach you how to do that too. Now, identify whether the statement represents an exponential function. A population of bacteria decreases by a factor of 1/6 every 4 hours. Is that an exponential or not? Does that sound like an exponential? Yes or no? Let's do a survey. Let's do a survey. A, yeah. B, no. A is good. B is bad, right? Okay, so A, we got an exponential. Raise your hand. Yeah, okay. B for bad? No, no exponential. C, I don't know. I don't have a clue. C for I don't have a clue, right? Okay, listen to me. You have to understand one thing. They're going to tell you how you're going to be able to identify stuff is this. Decreases by factor, right? Factor of 1/6. No, they're saying 1/6. It's taking 6 of it every what? 4 hours. So it's 1/6 raised to the x over 4. X over 4. Because it takes 4 hours for it to do 1/6 of a time, right? Does that make sense? It is exponential. So this would be 1/6 to the x over 4, right? So something happens every so often, like uh, rabbits multiply every 21 days or something. I don't know, some crazy thing, right? Populations or stuff. This is a time delay before it happens again, right? Like every 4 hours, like that. So it is the exponential. Okay, factor decreases by a factor. Okay. All right, so let's determine whether the equation represents exponential growth, exponential decay, or neither. Okay, so growth means that the base, and we got to look at this because these are all in the a times b raised to the x or t, right? Doesn't really matter. But here's your base, right? That's your base. So that base, if that base is greater than 1, we have a growth. So which one of these bases is greater than 1? Huh? There's 2 of them. The top one and the what? Okay, good. Now, But let's look at the exponent. The top one has a positive x, and the bottom one has a what? Negative x, right? And if you remember when you talk about negative power rule, what does negative power rule mean? It means you take it and move it from the numerator to the what? So that's really like 1 over 1.375, right? Does that make sense? 2 raised to the negative x is the same as 1/2 raised to the x. Those two are synonymous. Okay, they're the same. So you got to make sure that you understand. So yeah, this top one would be a growth. This bottom one would be a what? Decay. See the negative exponent? Okay. Or they'll put it as a fraction, and that fraction is a base between 0 and 1, not equaling 0, greater than 0, but not equaling what? 1, right? Why is the middle one not either one of those? Anybody know? Nope.
If you don't know what T is.
Nope. Nope. Yep. You're right. It ain't growth or decay, but why? You're exactly correct. She said it's because the variable's not up in the where. That's a polynomial, guys. Okay. You remember I said the qualifications, the x, the variable has to be up in the exponent, right? That was one of the things. So that's why. Okay. Listen up. We're done with that for right now. We'll come back and hit that at a later on, I guess, Monday, right?